up, guys? Welcome to section number 2. It's about chapter 3. We're going to see now stoichiometry, how to apply it to our rate laws. So remember this. Okay, let's have this reaction here. We got little capital letters are the species, and these are the stoichiometric values A, B, C, and D. First thing first, you want to relate everything to our limiting reactant and let it be in, let's say, in terms of our limiting reactant. So that's why we are dividing by A. And the thing here, guys, is, or the problem is that we may have, as we've seen before, rate of reactions as follows. This is an example. It depends on A and it depends on B. Now the problem, guys, is that how do we relate concentration of B in terms of conversion? Because remember, we've seen flows, which are flows of A, which are moles per unit time. We've seen concentrations, which is mole of A in volume. And we've seen conversion, or our reactions, which is moles of A reacted divided by the moles of A fed. So how can we relate these concentrations in terms of conversion? And not only conversion, but conversion of A, which is our limiting reactant. And the thing here is that if you're good in stoichiometry, then you're going to enjoy this course. If you are not good, then you're not going to like that much, because it's a little bit complicated how we're going to relate everything to our limiting reactant here, A. And why stoichiometry? Well, it will help us to relate rate of reactions, R of A, R of B, there's always a relationship here, and R of C here. So we can relate this, that's good. Concentrations, also concentration of A is always, you can relate them, concentration of B, and you can relate concentration of C. Flows, that's true, also F of A, you can relate it to F of B and F of C. And conversion, the conversion of A, you can relate it to the conversion of B and C in terms of A. So imagine having a concentration of B in terms of, or a function of A will be very nice. And yeah, not only B, also C and D. So imagine having a product in function of your limiting reactant. That's very nice, and actually I love this. I actually got this little like tip: one variable to rule them all, one variable to find them all, one variable to bring them all in the darkness, bind them. So you got one variable, or if you got every equation depending on this variable, then as you can see, we can, let's say, concentration and time. Since we have everything in terms of concentration of A, we will be able to plot and understand and work with all these problems. So before probably you're not getting the idea, we're going to make an exercise on this batch reactor. But let me break it in another video so you have it separate and see how we can relate the batch reactor to everything into our limiting reactants. What's up, guys? It's me, Chemical Engineering Guy. So if you like the video, why not push the like button? It really helps me to know if you're liking the videos, or if I should be changing something, or I should be adding something, taking out content, whatever. Also, sharing is caring. So if you got any kind of friends, teachers, colleagues, or whatever kind of person that might be interested in this type of content, why not share it? Sharing helps our community to grow faster in members and in content. If you want to keep track of my activity, videos, uploads, experiments, playlists, whatever content I'm getting on YouTube, be sure to click the subscribe button. Subscribing to the channel is totally free, guys. My dream is to create an online academy of chemical engineering, where everyone can access it in the world. Imagine a place in which the student, the teacher, and the engineer get the best of each other. Thank you guys for the support and the love.